Imagine you are flying on an airplane when the pilot makes an announcement. We are expecting some bumpy weather ahead. Please return to your seats and fasten your seatbelts. The pilot's message gives you time to take action to be safe. A similar alert that could save lives happens for earthquakes on the west coast of the United States and is called the Shake Alert Earthquake Early Warning System. The Shake Alert Earthquake Early Warning System uses over 2,000 seismometers and GPS sensors to detect earthquakes rapidly and alert people in the affected areas. It is managed by the United States Geological Survey and is operational in California, Oregon, and Washington. In a moment, we will describe how the Global Positioning System, or GPS, enhances and refines the Shake Alert system for major earthquakes. The Shake Alert system does not predict earthquakes. Instead, within seconds after an earthquake starts, the Shake Alert system rapidly estimates an earthquake's location, magnitude, and where dangerous shaking might occur. If the earthquake meets or exceeds a certain magnitude, the USGS and its alert delivery partners decide where to deliver Shake Alert powered alerts to cell phones and trigger automated actions that can protect people before strong shaking arrives, such as slowing trains and opening firehouse doors. The entire West Coast can experience large crustal earthquakes. In addition, the Pacific Northwest can experience especially destructive subduction zone earthquakes. All types of earthquakes could trigger the Earthquake Early Warning System. Characterizing the largest earthquakes is one area where scientists focus to improve the Shake Alert system. While rare, earthquakes with a magnitude greater than 7 have the greatest impact on human lives and infrastructure. It is extremely important to be able to quickly estimate the magnitude of major earthquakes so that alerts can be delivered to affected areas before shaking is felt. Although the Shake Alert system detects large earthquakes, it's challenging to reassess the magnitude quickly as the earthquake grows and, at the same time, also deliver an alert to all areas that could experience strong shaking. Therefore, the Shake Alert system is constantly being upgraded to improve timely alert delivery. One such upgrade has been to include GPS sensors, in addition to the existing seismometers, to more rapidly determine the size of these major earthquakes. Together, they give us a more complete picture of an earthquake as it unfolds. These two types of sensors complement each other well because they are sensitive to different properties of the shaking caused from passing seismic waves. Seismometers measure how fast the ground is shaking in terms of velocity and acceleration, whereas GPS sensors measure how far the ground moves up, down, and sideways as a result of an earthquake. High-precision GPS sensors, permanently attached to the ground, continuously monitor the motion of the Earth's surface and measure the distance and direction the GPS sensor and the ground have moved over time. The long-term tectonic motion is usually extremely slow, but earthquakes can cause sudden shifts of the land. The amount of displacement can be correlated with the size of the earthquake. Small earthquakes show small, localized shifts. During major earthquakes, rock slips along the length of very long faults. These earthquakes start small, but as the rupture travels along the length of the fault, more stored stress is released. The earthquake's magnitude grows, which means a greater area will feel strong shaking. While both seismometers and GPS sensors detect earthquakes, GPS data reveal the peak ground displacement caused by the ongoing earthquake and allow the Shake Alert system to more quickly and accurately update the estimated magnitude of such major earthquakes. This results in a Shake Alert powered alert being expanded to a broader area of additional locations where potentially damaging shaking will occur, and enabling more people to take immediate protective actions before shaking starts, such as drop, cover, and hold on. Of particular importance is the enhanced Shake Alert system network's ability to more accurately estimate the magnitude of major offshore earthquakes in the Pacific Northwest, especially those that could produce a tsunami. As the rupture grows, consecutive GPS stations show substantial offsets as the earthquake continues. If you are near or on the coast, or in a tsunami-prone area, as soon as you are able after the shaking stops, follow evacuation routes to higher ground or inland. Remember, the earthquake itself is your warning that a tsunami may be coming. During an earthquake, seconds matter, and immediate action can save your life. It is possible to receive an alert before, during, or after shaking arrives. As soon as you receive an alert or feel shaking, take action to protect yourself. The best way to do so is drop, cover, and hold on. To learn more about the Shake Alert system and how to prepare for and protect yourself during earthquakes in specific situations, please go to shakealert.org.